Hi, afternoon. Welcome to Pipelines for Systems Administrators. I'm Matt. I'm known as Prof Falcon just about everywhere, Twitter, GitHub, IRC, various other places. I started off as a developer of sorts, in the sense that I used to write ASP applications backed by Access databases on Windows 98. And then someone introduced me to Linux, and all of a sudden my world was a lot less painful. I realized that I could start running my own services, running my own email servers, database servers, that kind of thing. And that kind of led to various jobs, which then led to redundancy, during which time I took a break from IT and went off and did various things, including healthcare. Really interesting. There's a lot of things that you learn from healthcare that actually translate into IT. Stuff like if it's not written down, it didn't happen. Don't treat the symptoms. Treat what's actually causing the issue. But also, I realized that if a computer dies on you, it's a lot easier to bring it back. So I came back into IT. Unfortunately, I've been out for about 4 years, so I had to start from the beginning. So I went back into first-line support, second-line support, third-line support. Made it back up to systems administration, which was great. And then moved into consultancy, and cue pantomime boos and hisses. And that was good. Got me working with retailers, got me working outside of your usual hosting environments, all that kind of thing. Then I went back to doing systems administration because I got made redundant. That is a reasonably recurring theme. And would like to point out this is redundancy, not being fired. I want to make that quite clear. But yeah, went back to systems administration and worked for an organisation called Namesco, who are a web hosting company. Responsible for their shared hosting cluster. That's where I started to get interested in this idea of using monitoring and stuff like that to drive how you do configuration management and things like that. Then I went back to being a developer, which was kind of weird. It's kind of a roundabout route. I ended up being a Python developer for about 2.5 years working on OpenStack. But again, looking very much on the build pipeline side of things. And now I'm at DevOps Guys. We're hiring, by the way, so if anyone's looking for jobs and stuff, come and find me at the end. We are a consultancy, as well as providing managed operations, as well as coming in and educating your staff on how to do deployment pipelines from a development perspective, and business processes, and basically everything that DevOps encompasses. We can come in and either do it for you or help you out with your internal teams. So why pipelines for systems administrators? Well, something I've worked out over the last 5 or 6 years is that systems administration is very, very much event-driven. You can't do the kind of, oh, here's a nice block of a task, I'll sit down and I'll spend 8 hours listening to music, sorting that task out, and then I'll go home. Because I can guarantee you that at some point, either the MD isn't able to send a PDF document to a printer, or your production server's gone offline and someone needs to fix it. So it's very much an event-driven workflow. And no matter how hard you try, at some point, it's going to be 3 o'clock in the morning and there's going to be a pager going off to get you out of bed to fix something, which could also be the MD not being able to send a PDF to a printer. It's very reactive. It's not proactive. You can do your best to automate as much as you possibly can. And you can do your best to ensure that you've forecasted what the amount of traffic coming into your systems is going to be and all that kind of thing. But you are still going to get these 3 a.m. moments, and it's almost this kind of, it's 3 a.m. Do you know where your systems administrator is? We're also not always understood. A lot of that's down to personal hygiene, I'll admit. But there's also a lot of differences in the language between development, marketing, business processes, and systems administrators. And we're often heard as, I mean, that's pretty much how I think most people hear systems administrators when they're talking about stuff. Random words that don't seem to make any sense, but everyone's sat there nodding with very serious faces. And often we're not involved until deployment, or traditionally we haven't been involved until deployment. Now, this is a big thing, because what it actually means is that a lot of systems administrators are now very, very suspicious of this whole DevOps thing, because we've been sat in a silo having code thrown to us for the last 20-odd years. And now we're being told that the developers are going to do operations. Not really a good way to win friends and influence people. And I guess that kind of means I have to state what I mean by DevOps, which is possibly painting myself into a corner, but here we go. For me, DevOps is not about developers doing operations any more than it's about operations doing development, or just throwing all of your stuff into the cloud and hoping it works. For me, DevOps is about collaboration. It's about developers and operations teams and security teams and marketing teams and finance teams and everyone else working together to make sure that the business succeeds. It's got nothing to do with tooling. Doesn't matter whether you're using Jenkins, Go, Bamboo, Jira, the IBM tools or whatever. It's nothing to do with that at all. It's all about collaboration. So if you're not collaborating, if you have a DevOps team that sit over there away from everyone else, and they take the code from the developers and they take the operations stuff and root access from the operations team, you're not doing DevOps. You can call it what you like, but as far as I'm concerned, you're not doing DevOps. So there we go. So the story so far for systems administrators. We started off doing things by hand. 20 servers, configuring them by hand is painful. So we started writing bash scripts. We had worked one place where we had a load of email servers in a mail cluster and loads of scripts that configured them. And the final step was copy the XIM configuration file from an existing server. Fair enough. The next line in the documentation will haunt me till my dying day. If you don't have an existing XIM server, find someone in the company who can write an XIM config file for you. This is not good. So we started looking at configuration management. CF Engine was around at the time. This is 2007, 2008, something like that, I started looking at this. And I looked at it and went, that's great if you've got a doctorate in promise theory, but actually for me, and the way my mind works, CF Engine wasn't accessible. And Luke Keynes came along with Puppet. And all of a sudden, here's this declarative way with its own domain-specific language that I can use to say, that box over there should be a web server. And it goes, there you go, there's a web server. Brilliant. So then we start looking at virtualization. And I realized that by using virtualization and configuration management, you could build out a virtual copy of your infrastructure, test against that, throw the virtual infrastructure away, and then deploy your Puppet manifests into production knowing that they've been tested. So I wrote something called Cucumber Libvirt. How many of you know Cucumber? Okay, so you're familiar with the given, when, then syntax. This was, given that I've made changes to my XIM Puppet module, when I deploy a web server, when I deploy an email server, I can connect to port 25 and I can send and receive email. And this was basically a wrapper around Libvirt that then launched your systems. Yes?
You heard of Beaker or SverSpec?
Not at the time. This is 2009. So I wrote this back then, and then people wrote Vagrant and RSpec and ServerSpec and all that kind of stuff, and I sort of shelved this project quietly and let it go away. So we had this virtualization, so we started doing more configuration management because we'd made it really easy for ourselves to do this. And that was great. And so we started doing more virtualization, and then it started to get quite confusing. There's a project out there called Tripolo. It's part of the OpenStack project, and it allows you to run OpenStack on OpenStack. And at that point, it's turtles all the way down. And then we started to get more configuration management tools. And having had Chef in place, having sort of moved from Puppet to Chef for various reasons, which sadly I don't have time to go into now, but find me later and I'll bore you to death about it. We've then started to have recently things like SaltStack and Ansible. And I'm a huge Ansible convert, I have to say. I think it's a great bit of kit. That are designed to make it as easy as possible to manage your configuration. So let's take a look at pipelines. Pipelining is a really complex field. There's loads of tooling out there that claims that it is the best tool for the job, as you'd expect. There's a lot of complicated software as a service or off-the-shelf solutions available. And actually building pipelines is difficult. It's not an easy thing to do. And it's certainly not an easy thing to get right, because I've been trying for years and I'm not convinced I'm there yet. So we do need to define what a pipeline is. And to me, it's simple. It's a process by which the code or configuration progresses from the developer's workstation into the production environment. And when I say developer, I don't mean someone that's writing Python, Java, C#. I mean, it includes them. But in a lot of cases, the developers are actually the systems administrators that are writing their Puppet manifests, their Chef recipes, their Ansible roles, all that kind of thing. Yeah. It's a process that gets code into production in a safe manner. The tools are fairly immaterial. It's actually the process that matters. And I'll keep coming back to this. I have an opinion on which tools I like to use, but that doesn't mean I'm going to tell you guys that you have to use them. What's more important is that there's some way that you can safely get your code through all the testing it needs to do and into production. So in order to know when we've finished our pipeline, we need to know when we're done. Now, this is quite a controversial subject. I've seen all of these as definitions of done over the years. My manager told me to work on something else, therefore what I'm working on now is done. Code's been committed to the repo. Code's been committed to the repo with tests. It's an improvement. With tests that work, that's even better. And those tests are passing. Well, we're getting there. We're starting to get to a point where we've got something that we can almost trust. QA have told me those tests have passed. Now, I don't know how many of you work in a large enterprise environment with a QA department, but my experience is that unless QA know what the original specification was, they can tell you the tests have passed all they like, but they've got no idea as to whether the tests are actually testing the code that's written or meeting what the original user wanted. So I have mixed views on QA departments. I think you should have people embedded in the team of developers that can look at the test results and know what they're talking about. What can I say? I have seen people that just, well, I've closed the ticket, the work must be done. Yeah, great, okay. Code's in production. Yeah. I've heard all of these, but actually, as far as I'm concerned, you're not done until it's being monitored. Because how do you know whether your systems are working properly? How do you know whether the code you've written or not has been deployed successfully if you're not monitoring your production platform? And this comes back to what Alex and others have been saying today about this monitoring-driven development. You can't tell that your code is ready and working unless you're monitoring the entire infrastructure. So, with all of that said, let's take a look at some of the tools and then my approach to doing pipelines for systems administration. And like I say, this is very much a recommendation as opposed to do it now kind of thing. There's quite a few tools available today. Most of you will probably recognize a lot of them. Some of the ones you may not notice, may not be aware of. Octopus Deploy is a way of deploying Windows code. Some of my colleagues here work on the Windows side of things, deploying, that way, and that's, not me at all. I'm a Linux guy through and through. Dataloop.io are a monitoring as a service company who are coming online fairly soon. They do really cool things. Keep an eye out for them. I'm going to cover very briefly Vagrant, VirtualBox, OpenStack, Jenkins, Ansible, and Git, but no live demos. So this is based on a pipeline I created somewhere around 2009, 2010. There have been various iterations to get to the point where we're here, and you'll see whereas previously I wrote my own code, now I just steal other people's. So you start off with your code in source code management, something like Git. Git is my tool of choice for all of this stuff. It's just easy. I started to use SVN again for a customer the other day. It wasn't pleasant. And the nice thing about Git is it talks to Jenkins really well. Jenkins can say to Vagrant, please use Ansible to give me a virtual machine. Jenkins can then say to your monitoring scripts, please run these monitoring scripts against the VirtualBox I've just created and tell me whether you passed or not. So you can see this monitoring-driven development stuff already coming in. And then if they pass, it talks to Vagrant again because we might as well, it's in the stack. And Vagrant talks to Ansible, and Ansible talks to OpenStack and launches your virtual machines and deploys your monitoring scripts, which are the same scripts you've used to test the virtual machine. And I'm sure you can all see where this is going. And once you've got that in place, you're testing your production environment down here running on OpenStack with exactly the same tests that you used up here against your virtual representation that had all your new config changes. So you're automatically rolling out your monitoring that goes with your configuration changes. And that definitely makes you a rainbow unicorn ninja, without a doubt. So let's move on to monitoring-driven development in a bit more detail. This slide, to be honest, is purely gratuitous. I just love that picture. I just wanted an excuse to use it. So monitoring-driven development has actually been mentioned once or twice today. This morning I thought I was original coming up with that name. It turns out not so much, but hey, that's the internet. Why do I use monitoring scripts? Well, they test the code, which is your Puppet manifests or whatever, and your infrastructure at the same time. It's really quite difficult to unit test a server. You can't say, dear Ansible, what will that give me? I mean, there are ways of doing it, but it's quite difficult. And you can't guarantee that your Ansible role that configures Xim in a particular way will deliver email until you've spun up an email server and tried to send email through it. So you've already got monitoring scripts in your infrastructure that make sure you can send and receive email. So just reuse them as tests. But also, if you use Ikinga and Nagios, their exit codes for the scripts are 0 is fine, 1 is a warning, 2 is critical, anything else is unknown. This is great because as far as Jenkins is concerned, 0 is fine and anything else is bad. So if you run your monitoring scripts that you're going to be using in production with Ikinga, Nagios, Dataloop, whatever, and you run them against using Jenkins against the virtual machines, if you get anything other than OK being returned from those scripts, Jenkins is going to fail. And it's going to report back to you and say, something's gone wrong in your configuration. This is where I fell over. See what I did? So, lessons learned, because I've got 3.5 minutes left. 5 minutes, okay, even better. Sorry, you just put it on me for a while. You need everyone on the project to buy into this stuff if you're going to do it, okay? I worked in one company where only the immediate line managers brought into the idea of doing this and bought into the idea of starting off simple and then iterating and making things more complex. And because those higher up the chain either didn't get it or they were in the laggards that Linda mentioned earlier on this morning, it meant that they didn't want to get involved. And what started off as being an incredibly simple concept was suddenly overtaken, and we had to start using all sorts of complicated software that didn't really have a place in the pipeline. And 2 years later, having failed to deliver the project, The entire thing was scrapped and replaced with something that was a lot more simple. So do keep it simple, but get management involved. Get security involved. I'm very interested in the talk that's coming up next, which is about how to get CD past your security guys. I've found if you get them in at the start, you avoid it. How many of you are aware of the book, The Phoenix Project? Yeah? Okay. It's worth a read. It gives me Vietnam-style flashbacks, but it is worth a read. The whole thing there is, well, we don't tell security anything because they tell us to stop doing what we're doing. Get them involved at the beginning. They'll stop you a lot sooner, but the chances are you'll be able to negotiate with them. Get QA involved. Get the developers involved. And remember, I'm a systems administrator here. Okay. If I'm going to be rolling this out across a company, I want to make sure that not only are the sysads not involved in doing this, but the developers know that the systems administrators are adopting the same practices that they use. Because Sys-Admins, we can learn a hell of a lot from developers. I'd argue there's a few things that they can learn from us, but ask me about that in the pub later. Get everyone involved at the start. It's so important that everyone in the project has bought into it, because otherwise it isn't going to work. Also, start off small and iterate. Don't try and solve everything all at once. If you've got an edge case that turns up every 4,000 hours, then solve it when you get to hour 4,000. Or at least log a ticket, because if you haven't solved it by hour 8,000, you've probably refactored and it's gone away by then anyway. Okay? The Kanban style of to-do, doing, and done works really well for systems administrators. I'm not a Kanban expert by any means. I'm not going to start ramming Agile and all the rest of it down there, but having the 3 simple ticket states of this is what I need to do, this is what I'm working on, and this is what's in production and being monitored is great. Because if something does come in and there's an issue with your systems, then you can just say, okay, well, I'm working on all of these things, but actually, that's come in, it's a priority. I'm going to work on that. Now, what was I doing? Oh, yeah, I'm doing that. And you don't need anything more complicated than that, in my view. Don't overcomplicate things. That's probably the thing that I've repeated the most throughout the last 20 minutes or so. Automate as much as you possibly can. Use automation wherever you can. It will give you more time in the pub on a Friday night. Use open source software where people will let you. A lot of these problems have already been solved by the open source community. Find other people who have already solved your problems and find out how they did it. It's a lot cheaper learning from other people's mistakes. Abuse your Twitter contacts heavily. I use Twitter as a peer-reviewed RSS feed. Okay? It is, plus the odd account. But you know, it's a great place to just ping something out there and just go, anyone got a solution to this? You'd be amazed how many people go, oh yeah, we did that and it worked there, swiftly followed by a dozen other people going, yeah, well, we tried that approach and it didn't work, so we did it this way. So you certainly get plenty of choice about how to fix a problem, even if you may not actually get a proper solution to it. Attend conferences and the pub sessions afterwards. I have learnt more by getting drunk with people about how to solve problems I've got than, if I'm honest, I probably have sitting where you are listening to people like me waffle on for 25 minutes. And that's it, really. Any questions?
I'm a kind of naive, stupid developer, so forgive my question, but I kind of think of monitoring as look but don't touch, but you seem to have a different sort of, yeah, I can make a thing in the system, and then I guess your monitoring thing deletes that afterwards, whatever data trail it's. So like, if I've got a ticketing system,
yeah,
would your monitoring script create a ticket via email or what that
if you want it to?
That's what my tests do, and you're saying test by monitoring.
Okay, so I guess the kind of things we're testing are subtly different in the sense that, like I say, it's difficult for me to look at an Ansible role or an XIM config file, a mail server config file or whatever, and say, yes, that will definitely do what I want it to, without actually firing up the Exim server, the mail server, applying that config to it, and trying to do something with it. It differs from application testing in a massive way. I actually don't think that application testing is the right approach to take with servers, because by their very nature they are systems, they're not modules, they're not units. It's difficult to break it down. But yeah, I mean, there's no reason why your monitoring systems couldn't say, you know, oh, well, all of these tests failed, and therefore, you know, I want you to log these tickets into Jira or, you know, Track or whatever, saying these tests failed, you need to take a look at it. And what that does is the systems administrator then goes and looks at the monitoring results, looks at what's in the ticket, looks at the Jenkins jobs and all the rest of it in exactly the same way you would if you were doing unit testing or functional testing. So, okay, well, I think if I change that line there in that Ansible role or that Puppet manifest, if I change that bit of the configuration file, I can iterate on the code. I can do another git push, and Jenkins kicks in again and relaunches the infrastructure and tests like that. So it's subtly different to unit testing and functional testing and even integration testing to a point. But certainly, yeah, there's no reason why you couldn't
So
get...
you were talking about checking databases up, checking servers up.
Yeah,
checking
yeah, so is this service running and all the things like that. So it's... I don't necessarily see it as my role to ensure the correct data is in the database. To make sure that the database service is up and running, yes, absolutely, as the systems administrator, that is my role. To make sure that the correct usernames and passwords are in place so that developer code can connect to the database server, absolutely, that is my role. Is the data that the application is pushing into the database correct? Honestly, day to day, I probably don't care. I care about whether you can connect, and I care about whether you can shove data in. And because I personally like learning about the systems that connect to everything I'm doing, I probably would be interested in trying to track down that kind of thing. But from a testing point of view, as long as it's up, I can log into it and the services are running, we're done here. Yeah. So I hope that...
On your sorry to take a long time, guys, but on your Jenkins thing, you've got two suites of tests. One's run for application testing by developers, and the second suite.
Yeah, absolutely. And then probably actually a third suite of tests that takes the latest set of configuration code that's just passed all the tests and the latest set of application code that's just passed all the tests and munges them together and runs everything against it. So, yeah. Okay, cool. We'll have to cut it short there. Do come and find me later on if you've got any more questions. And thank you very much.